Picture this. The Starship Enterprise hurtles through the void of deep space, its crew steady at their posts when suddenly, the viewscreen erupts in a dazzling, violet haze. A wall of energy, vast and impenetrable, looms before them, the Galactic Barrier. For decades, Star Trek fans have marveled at this iconic moment, a fictional frontier where the laws of physics seem to bend. But what if this wasn't just brilliant storytelling? What if, hidden in the archives of NASA's most classified research, there's a kernel of truth to this sci-fi spectacle? The line between science fiction and scientific fact has always been thinner than we think. From communicators inspiring flip phones to holograms becoming reality, Star Trek has an eerie habit of predicting the future. But the Galactic Barrier isn't just another piece of futuristic tech. It's a cosmic mystery that might have roots in real astronomical phenomena. NASA's missions have uncovered strange, unexplained energy fields at the edges of our solar system, regions where charged particles behave in ways that defy expectation. Could these discoveries be the real-life echoes of Star Trek's visionary fiction? Or is there something even more profound lurking in the data, a secret NASA has yet to fully reveal? This is where the story gets electrifying. Imagine peeling back the layers of classified research, unearthing clues that bridge the gap between Hollywood fantasy and cutting-edge astrophysics. We're not just talking about coincidences, we're talking about a pattern, a trail of breadcrumbs left by scientists and storytellers alike. The Galactic Barrier might be fiction, but the forces it represents, cosmic radiation, magnetic anomalies, the very fabric of space itself, are very much real. So buckle up, because by the end of this journey, you might never look at Star Trek or NASA the same way again. The truth isn't just out there, it's waiting to be uncovered. In the original Star Trek series, the Galactic Barrier wasn't just another cosmic obstacle, it was a force of transformation, a boundary that defied understanding. Remember the episode where no man has gone before? The Enterprise, pushing the limits of known space, encounters this eerie, glowing wall of violet energy. It wasn't just a visual spectacle, it was a narrative bombshell. The barrier didn't just block ships, it altered the crew on a fundamental level, unlocking latent psychic abilities, rewriting human DNA as if space itself had a hidden agenda. The effects were striking, a swirling, luminous haze that seemed alive, pulsing with an almost sentient energy. But what made it truly unsettling was how it blurred the line between science and the supernatural. Crew members exposed to it didn't just gain powers, they became something more, or perhaps something other. It wasn't radiation or a simple energy field, it was a catalyst for evolution, a bridge to the next stage of human potential. And that's where things get fascinating, because in the real world, NASA has detected strange, high-energy particles at the edge of our solar system, anomalous cosmic rays that don't behave the way physics predicts. Could there be a connection? Star Trek's barrier was fiction, but the idea of space harboring forces that change us isn't as far-fetched as it sounds. Radiation exposure in space does alter human biology. Just look at the effects of long-term spaceflight on astronauts' bodies. But what if there's more out there? What if, buried in decades of astronomical data, there's evidence of something even stranger, a real-life phenomenon that echoes the eerie metamorphosis of Star Trek's Galactic Barrier? The series may have dreamed it up, but reality has a way of catching up to imagination. NASA's Voyager probes did something extraordinary. They pushed beyond the known boundaries of our solar system, into the vast, uncharted territory of interstellar space. And what they found there was anything but empty. At the edge of the sun's influence, where the solar wind collides with cosmic forces, lies a turbulent zone called the heliopause. This isn't just a theoretical boundary, it's a physical frontier, a place where charged particles crash and swirl in ways scientists still don't fully understand. The Voyagers recorded something bizarre as they crossed this threshold. Instead of a smooth transition into interstellar space, they hit a wall of energy, a chaotic magnetic barrier where particle densities spiked unexpectedly, as if space itself was pushing back. Sound familiar? It's almost like Star Trek's Galactic Barrier, that shimmering wall of violet energy that defied the Enterprise. The parallels don't end there. Just like in the show, NASA, a real-life data revealed strange fluctuations regions where cosmic rays intensified, where the rules of physics seemed to twist slightly. Then there's the heliosheath, a turbulent buffer zone just inside the heliopause. Here, the solar wind slows dramatically, piling up like cosmic traffic jam, creating a bizarre soup of energetic particles. Some scientists compare it to a kind of interstellar shoreline, where the tide of the galaxy meets the river of our solar system. But what's truly fascinating is how unpredictable it is: regions of sudden energetic surges, pockets of unexplained radiation. Again, the resemblance to Star Trek's barrier is uncanny, a glowing, unstable boundary that doesn't just mark a border, it does something to whatever passes through. Of course, NASA's findings aren't about psychic powers or genetic mutations. This is hard science, not science fiction, but the underlying idea that space itself might hold unseen forces, that the edges of our solar system could be stranger than we thought, feels ripped straight from a Star Trek script. Maybe that's the real revelation here. Sometimes, the wildest ideas in fiction aren't just fantasy. They're glimpses of possibilities, waiting for science to catch up. And if history is any guide, the universe always has a few more surprises in store. The universe is unimaginably vast, filled with billions of galaxies, each teeming with planets, so where is everybody? That's the haunting question at the heart of the Fermi Paradox. If life is statistically likely, why haven't we found evidence of other civilizations? One chilling answer lies in the Great Filter hypothesis. Some cataclysmic barrier prevents life from advancing too far, wiping out civilizations before they can spread across the stars. And here's where things take a spine-tingling turn. What if Star Trek's Galactic Barrier wasn't just a plot device, but a cosmic metaphor for this very idea? Think about it. The barrier in Star Trek didn't just block travel. It transformed or destroyed those who dared cross it. In an eerie parallel, the Great Filter suggests an invisible threshold, whether it's self-destruction through war, an unavoidable cosmic disaster, or even a fundamental flaw in evolution itself. Could the Galactic Barrier be a sci-fi echo of this existential dilemma, a visual representation of why we might never encounter alien civilizations? The implications are staggering. If the Great Filter lies ahead of us, some unavoidable doom lurking in our future, then crossing a barrier like the one in Star Trek might not just be dangerous. It might be apocalyptic, but here's the twist. If the Great Filter is behind us, meaning Earth is a rare fluke where life somehow beat the odds, then maybe the Galactic Barrier represents something else entirely. Maybe it's not a wall keeping us in, but a shield keeping something out. Star Trek's writers didn't just invent fantastical obstacles, they tapped into real scientific anxieties. The show's barrier mirrors the uncertainty in modern astrophysics. Are we alone because space itself is hostile? Are there regions of the universe, like NAS, a mysterious heliopause, that act as natural checkpoints, filtering out civilizations before they can expand? Or worse, could crossing certain cosmic boundaries trigger forces we don't yet understand? The terrifying beauty of the Great Filter is that we don't know where it is. Ahead, behind, both. But when fiction like Star Trek visualizes these unknowable dangers, it forces us to confront a profound question. If the universe is rigged against intelligent life, what does that mean for humanity's future among the stars? The answer might be hidden not just in science, but in the stories we tell about the final frontier. Voyager 1 and Voyager 2 didn't just cross into interstellar space, they stumbled into a cosmic puzzle. As these legendary probes ventured beyond the heliosphere, NASA expected a gradual fade of the sun's influence, replaced by the quiet hum of interstellar plasma. Instead, the data shocked scientists. Both probes recorded sudden, violent spikes in plasma density, like hitting an invisible wall of charged particles. Even stranger, cosmic rays, which should have flooded the probes as they left the sun's protective bubble, were partially blocked. Something out there was acting like a shield, bending the rules of deep space physics. These weren't minor fluctuations. At times, the plasma density surged to 40 times higher than predicted, as if the probes had dipped into an unseen current of energy. NASA's own reports called the phenomenon unexpected and poorly understood. Sound familiar? Star Trek's Galactic Barrier wasn't just a static obstacle, it pulsed with unpredictable energy, warping space and matter. The Voyagers found something eerily similar, a region where the fabric of space seemed to resist intrusion, where particles clustered in ways that defied models. Here's where it gets even weirder. The probes didn't encounter this barrier at the same distance from the Sun. Voyager 1 hit the plasma wall at about 120 astronomical units, while Voyager 2, traveling in a different direction, didn't cross it until 119. That inconsistency suggests this isn't a neat, symmetrical boundary. It's lumpy, uneven, almost alive in its variability. Scientists scrambled for explanations. Magnetic bubbles, interstellar winds, a previously unknown interaction between solar and galactic forces. The more they studied it, the clearer it became. This wasn't just a fluke. It was a feature of deep space, one that mirrored the chaotic, transformative energy of Star Trek's fictional barrier. And then there's the cosmic ray mystery. Normally, as you leave the heliosphere, cosmic rays from the galaxy should bombard you unimpeded. But the Voyagers detected something different, a filtering effect, as if some higher energy particles were being held back. It's almost as if the edge of our solar system isn't just a boundary, but a kind of gatekeeper. Could this be a faint, real-world echo of the barrier's ability to alter whatever passes through it? NASA data paints a picture of a universe far stranger than we imagined, one where the edges of star systems aren't passive borders, but dynamic, energetic interfaces. The Voyagers didn't just cross a line, they revealed a frontier that reacts. And if that doesn't send a chill down your spine, consider this: we've only mapped 2 paths through this unseen labyrinth. What else is waiting out there, hidden in the dark? Star Trek's Galactic Barrier didn't just block ships, it rewrote biology, turning ordinary crew members into beings with telepathic powers and godlike abilities. It's a thrilling idea, but how close does it come to reality? The truth about cosmic radiation's effects on human DNA is stranger and more unsettling than fiction. Astronauts venturing beyond Earth's protective magnetic field face a constant barrage of high-energy particles. and the damage these particles inflict on cells isn't just hypothetical. Studies on the International Space Station reveal that prolonged exposure to cosmic rays can shred DNA, increase cancer risks, and even accelerate aging. But here's the twist: radiation doesn't just destroy, it can also transform. Take NAS, a twin study, where astronaut Scott Kelly spent a year in orbit while his identical twin, Mark, remained on Earth. The differences afterward were startling. Scott's telomeres, the protective caps on chromosomes, temporarily lengthened, defying expectations. His gene expression shifted, with some changes persisting even after his return. And while he didn't develop telepathy, his body responded to space in ways science still can't fully explain. Now, imagine that same radiation amplified 1,000-fold, like the surges near the heliopause or in deep interstellar space. Could exposure to such extreme environments trigger mutations beyond mere damage? Could they, in some wild, speculative scenario, unlock latent potential in human DNA? The idea isn't pure fantasy. Some scientists theorize that cosmic rays might have played a role in Earth's own evolutionary history, potentially driving mutations that led to leaps in complexity. And in labs, controlled radiation has been shown to induce rare but dramatic genetic changes like bacteria evolving to survive lethal doses or plants developing entirely new traits. Of course, Star Trek's instant ESP is a stretch, but the underlying concept that space holds forces capable of rewriting life isn't entirely fictional. Then there's the darker side. Astronauts on future Mars missions could face radiation levels equivalent to a full body CT scan every 5 days. Shields can block some particles, but ultra-high-energy cosmic rays punch straight through, potentially scrambling neural pathways or triggering degenerative diseases. It's a grim trade-off. Venture deeper into space, and you gamble with your very biology. Yet, buried in that risk might be an eerie echo of Star Trek's vision. If radiation can harm, could it also, under the right conditions, enhance? The real mystery isn't whether space changes us, it's how far those changes could go. From mutated microbes to altered astronauts, the line between destruction and evolution is razor thin. Star Trek imagined a universe where crossing the wrong boundary could unlock human potential or doom it. Reality might not give us psychic powers, but it's already hinting at something just as profound, that the cosmos doesn't just surround us, it shapes us. What if the Galactic Barrier isn't made of glowing energy, but something far more enigmatic, something we can't even see? Enter dark matter, the universe's most elusive ingredient. Scientists estimate it makes up 85% of all matter in the cosmos, yet it refuses to interact with light, leaving it invisible to telescopes. But just because we can't see, it doesn't mean it's not shaping the universe in profound ways. Some astrophysicists speculate that dark matter could clump into dense, sprawling structures, cosmic walls, or filaments woven through the void. And if that's true, could one of these invisible formations be the real-life counterpart to Star Trek's barrier? The idea isn't as far-fetched as it sounds. Simulations of the universe's large-scale structure show dark matter acting like a scaffold, guiding the formation of galaxies along its unseen threads. In certain regions, these dark matter concentrations could become so dense they warp space itself, creating gravitational anomalies that deflect or trap particles almost like an unseen force field. Imagine a spacecraft encountering one of these zones. Sensors might detect nothing, yet the ship could shudder to a halt, its engines straining against an invisible tide. Sound familiar? It's eerily close to the Enterprise's struggle against the barrier's unexplained resistance. But here's where the science gets even wilder. Some theories suggest dark matter isn't just passive scaffolding. It might have unexpected interactions with ordinary matter. Hypothetical particles like actions or WIMP could produce weak but measurable effects, like scattering cosmic rays or emitting faint radio signals. If a dark matter structure were dense enough, it might even amplify these effects, creating localized regions of extreme particle turbulence. To a passing starship, it would feel like hitting a wall that science can't yet fully explain, but one that matches descriptions of Star Trek's barrier in unsettling detail. NASA's own observations add fuel to the fire. The agency's Fermi Gamma Ray Space Telescope has detected bizarre excesses of gamma rays near the Milky Way center, sparking debates about whether dark matter annihilations could be the cause. Meanwhile, gravitational lensing studies reveal patches of space where light bends too sharply, hinting at hidden mass concentrations. Could these be fragments of a larger, unseen architecture, one that might include a dark matter barrier at the edge of our cosmic neighborhood? The implications are staggering. If dark matter forms such structures, they wouldn't just block space travel, they'd redefine our understanding of the universe's boundaries. Star Trek's barrier was a test, a challenge to overcome, but a real dark matter barrier might be something far more profound, a natural checkpoint, a cosmic filter dividing one region of space from another. Whether it's a navigational hazard or a gateway to deeper mysteries, one thing's clear: the universe is hiding far more than it reveals. And if dark matter holds the key, humanity's journey to the stars might be stranger than even sci-fi dared to dream. Plasma cosmology offers a radical vision of the universe, one where electrified currents, not gravity alone, sculpt the cosmos. While mainstream astrophysics dismisses it as fringe science, this controversial theory paints a picture eerily similar to Star Trek's Galactic Barrier. Imagine the void of space not as an empty stage, but a seething ocean of charged particles, crisscrossed by vast filaments of plasma. These twisting rivers of electricity, some theorists argue, could form colossal boundaries between regions of space, shimmering with energy just like the barrier's violet haze. The parallels are startling. Plasma cosmology suggests that at the edges of galaxies or between star systems, these electrified structures might act as natural dividers, zones where magnetic fields grow tangled and particle densities spike. Sound familiar? It's almost a scientific echo of the Enterprise's encounter with that glowing, impenetrable wall. Even stranger, plasma's behavior under extreme conditions mirrors the barrier's transformative properties. In labs, high-energy plasma can self-organize into double layers, thin, explosive boundaries where voltages skyrocket, accelerating particles to near light speeds. Could something similar, on a cosmic scale, explain the chaotic energy surges NASA's Voyagers detected at the heliopause? Mainstream science remains skeptical, and for good reason. Plasma cosmology struggles to explain phenomena like galaxy rotation curves without dark matter, and its proponents often clash with established models. But here's the twist: even discarded theories can leave their mark. Sci-fi has a long history of borrowing from the fringes of science, repurposing bold, if unproven, ideas into compelling stories. Star Trek's barrier might not be literal plasma, but the essence is there: a universe crackling with unseen forces, where space itself hums with invisible currents. And sometimes, the fringe edges closer to fact. Consider Earth's own magnetosphere, a protective bubble of plasma shielding us from solar storms. Scale that up, and the idea of galaxy-sized plasma barriers feels less like fantasy and more like a question we just haven't answered yet. After all, NASA's own data shows the heliopause isn't the quiet boundary we expected. It crackles with unexpected energy. A real-life hint that space's frontiers might be more electrified than we thought. Whether plasma cosmology holds water or not, its boldest ideas linger in our imagination, blurring the line between dismissed hypotheses and the stories that inspire us to look deeper. The Galactic Barrier may be fiction, but the thrill of discovery it represents, that's as real as the mysteries still waiting at the edge of the solar system. NASA has always been a beacon of exploration, but behind the public missions and dazzling photos lies a shadowy world of classified research projects so secretive they're known only by cryptic code names like Sunstreak and Stargate. These weren't just fringe experiments, they were deep-dive investigations into phenomena that bordered on science fiction, from remote viewing to psychic espionage. But what if some of these buried programs held clues to something even bigger, something eerily close to Star Trek's Galactic Barrier? Take Sunstreak, a little-known offshoot of the CIA's infamous MK-Ultra program. Declassified documents reveal it wasn't just about mind control. It explored the idea that human consciousness might interact with unseen energy fields, even across vast distances. One declassified memo describes test subjects reporting visions of luminous barriers in deep space, structures that defied conventional physics. Coincidence? Maybe, but consider this. During the same era, NASA's early deep space probes began detecting anomalies at the solar system's edge, flashes of unexpected radiation, magnetic distortions with no clear source. Classified reports from the time labeled them instrument glitches, but whispers persisted that the data was being funneled into black-budget studies. Then there's the curious case of Project Horizon, a Cold War-era plan to establish a lunar military base. Publicly, it was about securing the high ground in space. But internal memos hinted at another objective, studying non-terrestrial energy signatures detected near the Moon's orbit. Astronauts on later Apollo missions reported brief but unexplained sensor spikes, momentary surges of violet-hued radiation, vanishing as quickly as they appeared. NASA's official explanation: cosmic ray interference. Yet decades later, a retired engineer from Lockheed let slip in an interview that some of that data was flagged for a compartmentalized program nicknamed Deep Shield, investigating, in his words, how to harden spacecraft against exotic frontier conditions. The most tantalizing clues come from the declassified archives of NASA, a breakthrough propulsion physics program. Buried in its reports are references to asymptotic boundary effects, theoretical zones where propulsion systems might encounter unmodeled resistance factors. One leaked diagram depicts a spacecraft approaching a curved, shimmering plane labeled Region of Nonlinear Field Interaction. The description is unnervingly reminiscent of Star Trek's Barrier, right down to the way it warps surrounding space. Of course, NASA insists these were purely hypothetical models, but when pressed, former program scientists admit off record that some calculations were based on anomalous readings from Voyager and Pioneer probes, readings that were later scrubbed from public datasets. So what's really going on? It's possible these are just scattered fragments of dead-end research, coincidentally mirroring sci-fi concepts. Or maybe, just maybe, they're breadcrumbs leading to a truth too destabilizing to disclose that deep space holds phenomena we're only beginning to comprehend, phenomena that blur the line between physics and something far stranger. Star Trek imagined a universe where exploration meant confronting the unknown. The unsettling question is, what if NASA already has, buried aboard the Voyager probes, alongside greetings from Earth and snippets of human culture, lies a cosmic treasure map, Pulsar maps, etched onto the golden records. These weren't just decorative, they were a deliberate attempt to show extraterrestrials how to find our solar system. But look closer, and something peculiar emerges. The pulsars selected aren't just random beacons, they form a network, a celestial breadcrumb trail that seems to avoid certain regions of space. Could this have been an unconscious warning, a subtle hint about cosmic hazards humanity wasn't even fully aware of? The maps pinpoint Earth's location using 14 pulsars ultra-dense, rapidly spinning neutron stars that emit precise radio pulses like interstellar lighthouses. Each one was chosen for its stability and uniqueness, creating a fingerprint unmistakably tied to our corner of the galaxy. But here's the twist. When you plot their positions in 3 dimensions, a curious pattern emerges. The paths between them curve around a vast, unexplored swath of space near the Orion Arm, almost as if skirting an invisible obstacle. Scientists at the time claimed it was just efficient routing, but what if there was more to it? Decades later, astronomers discovered that same region is riddled with anomalies, dark molecular clouds dense enough to shred spacecraft, rogue black holes drifting unseen, and gamma-ray burst remnants that could sterilize entire star systems. It's almost as if the pulsar maps were subconsciously tracing a safe route, avoiding a celestial minefield. Even stranger, some of those omitted regions align eerily with the turbulent zones NASA Voyagers later encountered at the heliopause places where space itself seems to push back. Then there's the silence. Of the thousands of known pulsars, why did NASA select these specific 14? The official explanation cites brightness and reliability, but declassified documents from the Jet Propulsion Laboratory reveal early debates about omitting pulsars near high interference regions. One memo even references a now declassified astrophysics study warning of uncharted energetic discontinuities along the galactic plane, a phrase hauntingly reminiscent of Star Trek's Barrier. Coincidence, or did the Golden Record's designers, armed with cutting-edge 70s astronomy, sense something modern science is only now beginning to grasp? The map's creator, astronomer Frank Drake, always insisted they were purely practical, yet in interviews he admitted the pulsars were also a warning, way to mark Earth's location only for civilizations advanced enough to decode them. Perhaps unintentionally, they did more than that. They sketched a boundary, a line in the cosmic sand where the rules of navigation might change. Whether by accident or intuition, the pulsar maps didn't just point the way home. They hinted at something far more profound, that the galaxy might be less of an open frontier, and more of a labyrinth with walls we're only beginning to sense. Long before Star Trek imagined the Galactic Barrier, ancient civilizations spoke of similar cosmic boundaries, mysterious, impassable walls in the heavens. The Sumerians, one of humanity's earliest cultures, described the bond of heaven and earth, an invisible force shielding their god's domain. Their cuneiform tablets tell of a violent celestial barrier called the Dur. Enkai, a place where only the divine could pass unscathed. According to their texts, mortals who dared approach it were struck down by radiances unseen. Could these be the same high-energy particles NASA probes later detected at the edge of our solar system? The parallels don't stop there. Egyptian hieroglyphs depict the sky goddess Nut as a glowing arc, her body studded with stars, but her outstretched arms form a clear boundary, separating the mortal world from the Duat, a realm of transformative energy. Texts describe the Duat as a place where souls were tested by fire before ascending, eerily mirroring Star Trek's barrier and its ability to mutate those who crossed it. Even the pyramid's alignment hints at something deeper. Their air shafts point directly to Sirius and Orion's belt, but one narrow passage in the Great Pyramid aims at nowhere, a dead end. Some researchers suggest it wasn't a mistake, but a symbolic warning. This far, no farther. Then there's the Dogon people of Mali, whose astronomical knowledge stunned scientists. Without telescopes, they described Sirius's invisible companion star and even its 50-year orbit facts modern astronomy confirmed only in the 19th century. But their most startling legend speaks of the Nommo, amphibious beings who descended from the sky, warning of a great veil in space that burns those unprepared. The descriptions are unsettlingly specific, a shimmering, violet-tinged force that changes the flesh. Sound familiar? It's almost as if ancient cultures encountered, or were warned about, a real version of Star Trek's barrier millennia ago. Even Norse mythology has its own cosmic boundary, the Ginnungagap, a yawning void filled with chaotic energies. Viking sagas tell of gods who crossed it, only to return transformed, their minds filled with forbidden knowledge. The parallels to modern astrophysics are striking. Plasma physicists note that the Ginnungagap's description matches theoretical models of interstellar plasma currents, those same twisting rivers of charged particles that might form natural barriers in space. So were these myths just imaginative storytelling, or could they be fragmented memories of extraterrestrial warnings? Ancient astronaut theorists argue that advanced civilizations might have visited Earth long ago, leaving coded guidance about cosmic dangers. If so, the Galactic Barrier isn't just sci-fi, it's a rediscovered truth buried in humanity's oldest stories. Whether through Sumerian tablets or Dogon oral traditions, the message seems consistent. The universe has edges we're not meant to cross lightly. And if that's true, then Star Trek's fiction might be closer to fact than we ever dared believe. Quantum physics shatters our most basic assumptions about reality, especially the idea that the universe exists as a fixed, objective truth. At the subatomic level, particles behave differently when observed, as if consciousness itself twists the fabric of existence. The famous double-slit experiment reveals this bizarre phenomenon. When scientists fire electrons through two slits, they act like particles if you measure them, but like waves if you don't. It's as if reality changes based on whether we're looking. Now, stretch that concept to cosmic scales. What if Star Trek's galactic barrier isn't a physical wall at all, but a quantum boundary, one that shifts or even materializes because explorers perceive it? This isn't just philosophy. NASA's own studies on quantum mechanics in space hint at stranger possibilities. The quantum space experiment, conducted aboard the International Space Station, found that particles in orbit exhibit even weirder behavior than on Earth, entangling over longer distances, reacting more dramatically to observation. Could the vacuum of deep space amplify these effects? Imagine a starship crew encountering a region where quantum uncertainty runs wild, where expectation literally shapes reality. Their instruments detect an energy field, their minds brace for resistance, and suddenly, the barrier appears, a self-fulfilling prophecy woven from collective belief. Then there's the Mandela effect in space. Astronauts report subtle discrepancies between their in-orbit experiences and mission logs, tools floating where they shouldn't, fleeting shadows with no source. Most dismiss it as cosmic ray, induced hallucinations, but what if it's more? Soviet cosmonauts on early missions described a phenomenon they called the overview effect glitch, moments where space itself seemed to stutter, rewriting brief instants of perception. Science can't yet explain it, but quantum theory offers a provocative clue. In a universe where observation alters reality, could deep space, with its lack of familiar reference points, become a canvas for the mind's unspoken expectations? The implications are staggering. If the galactic barrier exists as a quantum boundary, then crossing it might not require shields or warp drives, but a radical shift in consciousness. Ancient mystics spoke of veils between worlds, barriers that dissolved only for the enlightened. Modern physics might be echoing that idea in equations. The universe, it seems, doesn't just contain mysteries, it responds to them, and that raises a chilling question. Are some frontiers locked not by distance or energy, but by the limits of what we're ready to perceive? Stephen Hawking's warning echoes like a ghost in the machine of space exploration, a chilling reminder that not all frontiers are meant to be crossed. The legendary physicist didn't just caution against sending messages into the void, he framed it as a survival imperative. In his view, advanced civilizations might not just ignore us, they could erase us, the same way humanity bulldozes an anthill without a second thought. But what if the danger isn't just what's out there? What if the real threat is us, and the universe knows it? This is where Star Trek's Galactic Barrier takes on a darker, more provocative meaning. Imagine it not as a natural phenomenon, but as a cosmic quarantine, a filter designed to contain species until they're ready for the broader galaxy. Hawking's nightmare scenario paints humanity as the reckless child playing with matches in a fireworks factory. If that's true, then the barrier might serve a terrifying dual purpose, shielding Earth from external threats, while also preventing us from becoming the threat. After all, look at our track record: nuclear weapons, climate collapse, resource wars. Would an advanced civilization trust a species like ours with interstellar travel? The evidence isn't just philosophical. Fermi's paradox, the eerie silence of the universe, fits uncomfortably well with this idea. If intelligent life is common, why does space feel so empty? One harrowing answer: something suppresses it. Maybe not a physical barrier, but something far more subtle, an evolutionary checkpoint, a test of maturity. Fail it, and you never leave your solar system. Pass it, and the gates open. The great filter might not be behind us, it might be ahead, and Star Trek's glowing wall could be its starkest metaphor. Hawking's warning gains grim weight when you consider humanity's own history of colonization. Every time an advanced culture encountered a less technologically developed one, the results were catastrophic: disease, enslavement, genocide. Now flip the script. What if we're the primitive civilization this time? The galactic barrier, in this light, isn't fiction. It's a cosmic mirror, forcing us to confront our own capacity for destruction before we're allowed to roam the stars. The most unsettling possibility: we might have already triggered the alarm. Radio broadcasts, nuclear tests, space probes carrying maps to Earth. If the universe has safeguards, we've been tripping them for decades. NASA Voyagers, carrying golden records of our existence, are now drifting toward the heliopause, the very region where space seems to push back. Coincidence? Or the first flicker of a system designed to keep dangerous species contained? Hawking didn't live to see humanity's next steps in space, but his warning lingers like a shadow. Whether the barrier is plasma, dark matter, or something beyond our understanding, one truth remains: the universe might not just be stranger than we imagine. It might be wiser, and until we prove we can wield the power of the stars without self-destructing, that glowing wall, real or symbolic, might be the only thing standing between us and a fate worse than silence. Ever found yourself absolutely certain about a fact only to discover you're completely wrong? It's called the Mandela effect, that eerie phenomenon where large groups of people share the same false memory. And here's where it gets wild. Some people swear they've read about a real galactic barrier in old science textbooks or glimpsed it in documentary footage. But here's the twist: those references don't exist. There's no NASA report, no historical astronomy paper describing a glowing, violet energy field at the edge of the solar system. So why do so many insist they've seen proof? Blame it on Star Trek's cultural fingerprints. The show didn't just entertain, it rewired how we imagine space. Think about it. Flip phones exist because of communicators, tablets because of pad, even voice assistants because of the ship's computer. But the Galactic Barrier did something subtler. It colonized our collective memory. The image of Kirk's Enterprise battling that luminous wall is so iconic, so viscerally striking. It seeped into our mental landscape. Psychologists call this source confusion, where fiction bleeds into perceived fact. It's why some people vividly recall the Berenstain Bears being spelled Berenstein, or Darth Vader's infamous "Luke, I am your father" line, which, by the way, he never actually says. But the Barrier's false memory is different. It's not just misquoted dialogue, it's an entire phenomenon conjured into existence by sheer cultural osmosis. Consider how often sci-fi shapes real science. Astronomers named the hypothetical planet 9 after Star Trek's Vulcan. SpaceX's drone ships borrow names from the culture novels. When fiction feels plausible enough, our brains slot it into reality like missing puzzle pieces. And Star Trek's Barrier, it's the perfect storm, rooted in real cosmic mysteries like the heliopause, wrapped in dazzling visuals, and sold with the show's trademark pseudo-scientific jargon. Of course, it feels real. Here's the kicker: this isn't just about mistaken trivia. It reveals something profound about how humans process discovery. Our brains are pattern-seeking machines, desperate to make sense of the unknown. When faced with gaps like the unexplored edges of our solar system, we fill them with the most compelling narratives at hand. Star Trek gave us a template, a vivid shorthand for cosmic frontiers. So when Voyager's data revealed strange energy surges at the heliopause, our collective imagination whispered, "See, just like the show predicted. Never mind that plasma physics and warp drives are light years apart." The story feels true, and maybe that's the real power of sci-fi. It doesn't just predict the future, it shapes how we see the present. The Galactic Barrier might be fiction, but the longing it represents, for boundaries to push, mysteries to solve, is achingly real. So next time someone swears they read about NASA barrier studies, smile. It's not a lie. It's proof that the best stories don't just stay on the screen. They jump the rails of reality and keep on going. NASA's Artemis program isn't just about footprints and flags. It's humanity's next great leap into the cosmic unknown. And while the mission officially aims to establish a sustainable lunar presence, the unspoken truth is this: every time we push further into space, we stumble upon phenomena that rewrite the textbooks. The Moon itself sits perched at the edge of Earth's magnetosphere, a natural laboratory for studying how charged particles and cosmic barriers behave. When astronauts return to the lunar surface, their instruments will be scanning for solar wind interactions, radiation spikes, and plasma anomalies, precisely the kinds of energetic puzzles that make Star Trek's Galactic Barrier feel less like fiction and more like foresight. Consider the Gateway Station, NAS, a planned lunar outpost. Orbiting in a unique halo trajectory, it'll dip in and out of the Moon's wake, where Earth's magnetic field stretches and warps like taffy. This region, called the distant retrograde orbit, is a bubbling cauldron of electromagnetic turbulence. Scientists expect to find magnetic reconnection events, sudden snaps in the field lines that unleash bursts of energy. Sound familiar? It's a microscopic echo of the chaotic particle surges Voyager detected at the heliopause. If similar phenomena exist on a solar scale, Gateway's date might hint at how larger cosmic barriers could form. Then there's the Mars question. Red Planet missions will traverse the deep space between Earth and Mars, crossing through the interplanetary void where cosmic rays and solar winds dance unpredictably. Modern probes already detect flux tubes, invisible tunnels of magnetized plasma winding through space. Some astrophysicists speculate these tubes could cluster into vast, unrecognized structures under the right conditions. Picture a spacecraft hitting a patch of space where these tubes knot together, creating a sudden spike in particle density. To the crew, it might look like a brief, shimmering disturbance, or something far more imposing. Artemis also carries another game-changer, the Orion spacecraft's heat shield. Designed to withstand re-entry at 25,000 miles per hour, its real test won't just be atmospheric friction, it'll be deep space radiation. The shield's multilayer insulation is essentially a cosmic radiation detector, absorbing and dispersing high-energy particles. If unexplained energy spikes appear in its data, patterns that don't match known solar or galactic sources, it could reignite the barrier debate. After all, NAS, previous missions didn't have shields this sensitive. What if they missed subtler signatures of something bigger? But here's the tantalizing part. Artemis is just the beginning. The program's long-term vision includes a sustained human presence beyond Earth, which means more eyes and instruments pointed at the darkness. Every moonwalk, every soil sample, every scan of the lunar horizon adds to our understanding of how space really works. And history shows us that when humans explore, they find the unexpected. The Apollo missions brought back moon rocks that appended theories of lunar formation. Voyager's heliopause detections shocked astrophysicists. Who's to say Artemis won't uncover its own cosmic curveball? Perhaps the most provocative idea is this: what if the barrier isn't something we find, but something we trigger? Modern spacecraft emit complex electromagnetic signatures, something ancient probes like Voyager couldn't do. As Orion and later ships pulse with activity, could they inadvertently interact with hidden structures in space? Plasma physicists warn that high-energy systems can excite dormant particles, creating temporary walls of accelerated charge. It's speculative, but not impossible. After all, we've already seen how nuclear tests in the 50s accidentally created artificial radiation belts around Earth. If human activity can reshape near-Earth space, what might it do deeper in the void? The Artemis generation stands on the threshold of a new era, one where every mission carries the potential to blur the line between science and science fiction. Whether they encounter a barrier-like phenomenon or not, the real revelation might be how little we still understand about the universe's frontiers. And sometimes, the greatest discoveries begin not with answers, but with the right questions asked boldly, just like Star Trek taught us. For centuries, we assumed life could flourish anywhere in the cosmos, but modern astronomy paints a far more startling picture. the galaxy might be riddled with invisible fences, dividing habitable oases from lethal dead zones. Enter the concept of the galactic habitable zone, a thin, swirling band within the Milky Way where conditions are just right for life to emerge and survive. Too close to the galactic center, and lethal gamma-ray bursts or supernova explosions would sterilize fledgling worlds. Too far out, and stars lack the heavy elements needed to form rocky planets. Earth sits perfectly within this Goldilocks ring, but here's the chilling implication. What if this zone isn't just a happy accident? What if it's a cage? Exoplanet discoveries add weight to this eerie possibility. NASA, a Kepler telescope, found thousands of worlds, but the vast majority orbiting red dwarfs, stars prone to violent flares that would strip away atmospheres, or clustered in chaotic multi-star systems where stable orbits are nearly impossible. Meanwhile, the rare Earth-like planets we've spotted almost all orbit within the same galactic sweet spot as our solar system. It's as if the universe has drawn a chalk line, whispering, life may thrive here, but not beyond. Now, layer Star Trek's Galactic Barrier onto this cosmic blueprint. The show's violet wall didn't just block travel, it enforced a boundary, separating known space from realms too dangerous or too transformative for unprepared civilizations. Could a real galactic habitable zone function the same way, not as a glowing energy field, but as a statistical moat? After all, the deadliest regions of the galaxy aren't marked by warning signs, they're silent killers, wiping out life with radiation or gravitational chaos before it ever gets a foothold. The data gets even stranger when you examine Earth's own history. Fossil records show mass extinctions arriving like clockwork every 26 million years or so, as if something, perhaps our solar system's periodic journey through the Milky Way's spiral arms, triggers catastrophe. Astronomers call this the Shiva hypothesis, named after the Hindu god of destruction. It suggests even within the habitable zone, survival might require navigating cycles of peril. Star Trek's barrier, then, could be more than fiction. It might symbolize the brutal filters that winnow life from the cosmos. Then there's the Great Filter Paradox. If the universe is so vast, why haven't we found other civilizations? One grim answer: something stops life from advancing too far. Maybe it's not an alien force field, but the galaxy's own architecture, regions of space so hostile they act like natural firewalls. Imagine a young species finally reaching for the stars, only to discover their system is encircled by a minefield of black holes, magnetars, or gamma-ray burst corridors. The barrier wouldn't need to glow, it would simply be, yet hope flickers in the shadows. Recent exoplanet surveys hint at something extraordinary: a handful of worlds orbiting stars outside the traditional habitable zone, somehow thriving against the odds. These outliers defy models, suggesting life might be more tenacious than we thought. Perhaps the galaxy's safe zone isn't a prison, it's a nursery, training life until it's ready to venture beyond. If so, Star Trek's barrier takes on new meaning, not a wall, but a graduation test, one humanity might someday face, if we can survive long enough to take the first step. Black holes aren't just cosmic vacuum cleaners, they're the universe's ultimate dead ends. Regions where space and time twist into knots so tight, even light can't escape. At their edges lies the event horizon, a point of no return that shreds stars into spaghetti and traps everything forever. In a way, it's the most extreme barrier nature has ever devised. So what if Star Trek's galactic barrier isn't some exotic energy field, but something far more primal, a network of black holes, woven together like an invisible fence around the galaxy. The idea isn't as wild as it sounds. Physicists have long theorized about primordial black holes, tiny, ancient relics from the Big Bang that could be peppered throughout space. Unlike the monstrous black holes we've imaged, these could be as small as an atom, yet still pack the mass of a mountain. In theory, a dense enough cluster of them could create a diffuse but impenetrable boundary. Picture millions of these microscopic traps scattered across a region of space like cosmic landmines. To a passing starship, it wouldn't look like a glowing wall, it would be subtler, deadlier. Sensors might detect sudden gravitational ripples, localized distortions where space itself seems to crumple. Here's where the parallels get spine-tingling. Just like Star Trek's barrier warped the minds and bodies of those who crossed it, a black hole network would have its own nightmarish effects. The intense tidal forces near even a tiny black hole could stretch atoms apart, creating bursts of lethal Hawking radiation. And because these objects would be invisible to the naked eye, a ship might not realize it had strayed into the danger zone until it was too late. It's the ultimate cosmic booby trap, a barrier that doesn't just block, but annihilates. NASA's own observations add fuel to the fire. The agency's Fermi Gamma Ray Space Telescope has detected bizarre, unexplained flashes of energy from deep space, some lasting mere milliseconds. One leading hypothesis: collisions between primordial black holes. If these objects are real and abundant, they might naturally cluster in certain regions, forming a patchy but effective barrier. Even stranger, advanced civilizations, if they exist, might deliberately exploit this phenomenon. Imagine a Kardashev-type 3 civilization rearranging black holes like chess pieces, creating a defensive perimeter around their territory. The Galactic Barrier wouldn't be natural, it would be engineered, but here's the twist: black holes don't just destroy, they might also transform. Theoretical work on quantum information suggests that whatever falls into a black hole isn't truly lost, it's scrambled, remixed, and potentially ejected over eons as chaotic radiation. In a perverse way, that mirrors the barrier's ability to rewrite biology in Star Trek. Matter passing through a black hole's event horizon might not return intact, but it could re-emerge as something unrecognizable. The same could be true for consciousness. Wild as it sounds, some physicists speculate that advanced beings might use black holes as quantum computers or even gateways, reshaping whatever enters into new forms. The chilling takeaway: if the Galactic Barrier exists, it might not just be a wall, it could be a factory, a cosmic assembly line where the universe itself reprograms anything bold enough or foolish enough to cross. Whether natural or artificial, black holes represent the darkest, most enigmatic frontiers of physics. And if they're lurking at the edges of our galaxy, the message is clear: some boundaries aren't meant to be tested. At least not twice. The CA's Stargate project reads like something ripped straight from a sci-fi script, because in many ways it was, for over 2 decades, the U.S. government poured millions into researching psychic phenomena, training operatives in remote viewing, a technique to spy on distant locations using nothing but the mind. Declassified documents reveal startling successes, viewers sketching hidden Soviet facilities, predicting troop movements, even locating downed aircraft with chilling accuracy. But buried in those files are stranger details: reports of viewers describing luminous energy fields in deep space, barriers that defied physics and seemed to pulse with awareness. Sound familiar? It's almost as if these psychics were glimpsing Star Trek's Galactic Barrier decades before it aired on television. NASA's involvement in these experiments remains shrouded in secrecy, but scattered clues suggest the agency took psychic research seriously. Astronaut Edgar Mitchell, the sixth man to walk on the Moon, became obsessed with consciousness studies after his Apollo mission, founding the Institute of Noetic Sciences to explore the mind's untapped potential. Declassified memos hint that Mitchell wasn't alone. NASA quietly consulted with Stargate's remote viewers during the Cold War, seeking an edge in the space race. One particularly bizarre transcript describes a viewer locked onto a violet energy lattice near Jupiter, a structure that allegedly disrupted instruments and induced visions in anyone who perceived it. The session was abruptly classified above top secret, but the implication lingers. What if NASA, a new space, held phenomena that could alter human perception? The parallels to Star Trek's Barrier are impossible to ignore. In the show, exposure to the violet energy triggered latent psychic abilities, telepathy, precognition, even matter manipulation. Stargate's files echo this eerily. Multiple viewers reported sudden, unexplained surges in intuitive ability after focusing on space-based targets. One operative, Joseph McMonagle, claimed to have seen future spacecraft designs during sessions, blueprints that later matched classified NASA concepts. Were these glimpses of real technology, or something more unsettling proof that the human mind, under the right conditions, could tap into forces beyond conventional physics? The most tantalizing and controversial thread connects these experiments to modern neuroscience. Studies at institutions like the HeartMath Institute reveal that human consciousness can influence electromagnetic fields, a phenomenon called psychoenergetics. If the mind can interact with energy at a distance, could a massive cosmic barrier, like the one in Star Trek, act as an amplifier? NASA's own research on astronauts' brainwaves in zero-G shows unusual synchronization patterns, as if space itself tweaks neural activity. Combine that with Stargate's findings, and a wild possibility emerges. The barrier might not just mutate biology, it could unlock latent mental capacities by resonating with consciousness itself. Of course, mainstream science dismisses remote viewing as pseudoscience, and NASA officially denies any involvement in psychic research. But the deeper you dig, the harder it is to ignore the overlap between fiction and classified reality. Star Trek envisioned a universe where space could rewrite human potential. The Stargate files suggest someone, somewhere, believed it wasn't just possible, it was already happening. Whether through classified programs or cosmic accident, the line between psychic fiction and scientific fact has always been thinner than we think. And if the mind truly can reach beyond the stars, what else might be waiting out there, just beyond the edge of perception? On August 15, 1977, a radio telescope in Ohio picked up something extraordinary. A 72-second burst of radio waves so powerful, so unnatural in its intensity, that the astronomer who discovered it scrawled, "Wow," in red ink on the printout. Decades later, the WOW signal remains one of the most tantalizing mysteries in the search for extraterrestrial intelligence. But what if it wasn't just a message from aliens? What if it was evidence of something even stranger, a signal warped by an unseen barrier in the depths of space, like an interstellar SOS filtered through cosmic static? The WOW signal's frequency sits smack in the hydrogen line, a quiet band of the spectrum where natural cosmic noise is minimal, making it an ideal watering hole for civilizations trying to be heard. Yet the signal's structure was bizarre. It wasn't a repeating pattern or a discernible code, but a sharp, singular spike, as if someone had briefly flicked a cosmic flashlight in our direction. Scientists have scoured the same patch of sky for years, but it never repeated. That absence is what makes the barrier theory so intriguing. Imagine if the signal didn't originate from its apparent source near the Sagittarius constellation, but from beyond something, an energetic boundary that distorted or refracted the transmission, like light bending through frosted glass. Plasma physics offers an eerie parallel. In labs, dense plasma can twist radio waves, scattering their frequencies or even briefly trapping them before release. If a similar structure exists in interstellar space, a vast, turbulent zone of ionized particles, it might explain why the wow signal was so intense yet fleeting. The barrier wouldn't just block, it could act as a lens, magnifying distant signals unpredictably before they vanish into noise. NASA's own studies on solar wind turbulence show how plasma can shred and distort electromagnetic waves, creating transient hotspots of signal clarity. If a natural plasma barrier exists light years away, the wow signal might not have been a deliberate broadcast, but a cosmic accident, a message scrambled by the very fabric of space. Then there's the chilling possibility of artificial filters. If an advanced civilization did erect something akin to Star Trek's Galactic Barrier, whether as a shield, a quarantine, or a test, it might not be perfectly opaque. Signals could bleed through intermittently, warped by whatever mechanism powers the structure. The wow signal's bizarre frequency shifts could mirror the effects of penetrating an engineered boundary, like radio static crackling through a force field. Even stranger, some cryptographers note that the signal's intensity pattern loosely matches a Fibonacci sequence, a mathematical ratio found in everything from galaxy arms to seashells. Was that a deliberate signature or a distortion caused by passing through a quantum filtering barrier? The most haunting question isn't where the wow signal came from, but what happened to it. If a cosmic barrier exists, it might not just refract signals, it could absorb them, explaining why we've never heard it again. Like a voice calling from the other side of a waterfall, the message might be a one-time fluke, a fleeting glimpse of what lies beyond the distortion. Or worse, what if it wasn't a greeting at all, but a warning, a distress call from a civilization that dared to cross a line we don't yet understand? The silence that followed could be the most ominous message of all. Deep in the void between stars, the Voyager probes picked up something unexpected, not silence, but a steady, eerie hum. This faint vibration, detected in the interstellar medium, isn't the random noise of cosmic rays or solar winds. It's a persistent, low-frequency drone, almost like space itself is resonating. Scientists initially dismissed it as instrument artifact, but the hum persisted, defying easy explanation. Now, some researchers wonder, could this be a whisper of something far larger, a faint echo of a cosmic structure so vast it eludes direct observation? The hum's properties make it stranger still. Unlike the chaotic crackle of plasma or the erratic pulses of distant pulsars, this signal is oddly uniform, thrumming at frequencies around 3 kHz. It's not tied to any known stellar activity, and it doesn't match models of interstellar particle interactions. In fact, the only comparable phenomenon in nature is the deep, resonant vibration of a massive object like a drumhead trembling after being struck. That raises a provocative question. What if the hum isn't just background noise, but the faint reverberation of an immense, unseen boundary? Think of it like this. Drop a pebble into a still pond, and ripples spread outward. Now imagine the pond is light years wide, and the pebble is something far more massive, a disturbance in the fabric of space itself. The hum could be the aftermath, the lingering tremor of an event or structure so colossal it warps the interstellar medium. Star Trek's Galactic Barrier was depicted as a turbulent, glowing wall. But what if the real thing is subtler, detectable not by light, but by its gravitational or electromagnetic aftershocks? The Voyagers might have stumbled upon the faintest fingerprint of something much bigger, lurking just beyond our sensors' reach. Supporting this idea are the probe's other detections, unexplained magnetic kinks, and sudden particle accelerations in the same regions where the hum is strongest. These anomalies don't fit standard models of interstellar space, which predicts a relatively smooth, quiet environment. Instead, they hint at hidden structures, perhaps vast sheets of magnetized plasma or dark matter filaments. If such formations exist, they could act like cosmic drumheads, vibrating as energy passes through them. The hum, then, wouldn't be random. It would be a signature, a clue that space isn't empty, but threaded with invisible architectures. Even more intriguing is the timing. The hum grew louder as the Voyagers moved farther from the Sun, peaking as they crossed fully into interstellar space. Coincidence, or evidence that the probes were moving through layers of something, a boundary zone where the rules of physics shift slightly. On Earth, we're familiar with how sound changes when passing through different materials. Think of voices muffled by a thick wall. The interstellar hum could be space's version of that effect, a subtle distortion caused by moving through an interface we don't yet understand. Of course, skeptics argue the hum is just an artifact of the Voyager's aging instruments or an odd interaction with their power sources. But here's the problem. Both probes detected it, decades apart, on opposite trajectories. The odds of identical glitches are vanishingly small. That leaves two possibilities. Either we're misinterpreting a mundane phenomenon in spectacular fashion, or we're hearing the first hints of a cosmic frontier far stranger than we imagine. The hum's true nature remains a puzzle, but its implications are profound. If it's evidence of a larger structure, even indirectly, then Star Trek's barrier might not be pure fantasy. It could be an exaggerated vision of a real cosmic phenomenon, one we're only now learning to detect. And if that's the case, the next question is unavoidable. What else is out there, vibrating just beneath the threshold of our perception? The universe, it seems, isn't just vast. It's humming a tune we're only beginning to hear. Science fiction has always been more than just entertainment. It's a blueprint, a roadmap for the human imagination, priming us for revelations we're not yet ready to grasp. Star Trek's Galactic Barrier might seem like pure fantasy, but history shows us again and again that the wildest ideas in fiction have a habit of leaking into reality. Take communicators. Flip phones were a pipe dream until Star Trek showed them in the hands of Kirk and Spock. Tablets, the show's pad, looked suspiciously like the devices we swipe today. Even video calls, now mundane, were once the stuff of sci-fi daydreams. The line between fiction and fact isn't just blurry, it's porous, with ideas slipping across like whispers from the future. But what if this isn't just coincidence? Some theorists argue that sci-fi serves as predictive programming, a way to soften the shock of radical discoveries by seeding them in our collective consciousness, long before science catches up. Arthur C. Clarke famously wrote about geostationary satellites decades before they became reality. Jules Verne envisioned moon landings complete with capsule splashes in the ocean, uncannily close to Apollo's real-world missions. Even H.G. Wells described atomic bombs in startling detail, years before physicists unlocked nuclear fission. These weren't lucky guesses, they were visions, glimpses of a future already taking shape in the hidden currents of human progress. Now consider the eerie case of the warp drive. For years, faster-than-light travel was dismissed as pure fantasy, violating Einstein's unshakable speed limit. Then came Miguel Alcubierre's theoretical warp bubble in 1994, a mathematically plausible way to bend space itself, sidestepping light-speed constraints. NASA Eagleworks Lab even began testing miniature versions, hunting for quantum anomalies that might hint at a real-world breakthrough. Coincidence, or did Star Trek's warp core, pulsing on screens since the 60s, prime scientists to take the idea seriously? The truth might be stranger. Fiction doesn't just predict the future, it shapes it, giving researchers permission to explore concepts that once seemed absurd. Then there's the holodeck, a fantasy of tactile, immersive virtual reality, dismissed as impossible until haptic feedback suits and VR headsets turned it into a billion-dollar industry. Or the replicator, a machine that materializes objects from pure energy. Today, 3D printing and molecular assembly are inching us toward that very reality, one layer at a time. Even the universal translator, once pure fantasy, now powers apps that decode languages in real time. The pattern is undeniable. Sci-fi dreams become real-world tools, often with unsettling precision. But here's the twist. What if this predictive power isn't just about gadgets? What if it extends to cosmic truths? Ancient myths warned of sailors reaching the edge of the world, only to tumble into the abyss. Later, sci-fi warned of black holes, invisible, inescapable whirlpools in space. Now we've photographed one. Star Trek's Barrier might follow the same arc, first a story, then a hypothesis, then, perhaps, a discovery. The universe doesn't care what we believe, but human imagination. That's a force of nature all its own. And when fiction and science finally collide, the result isn't just progress, it's revelation. NASA has always been a beacon of transparency, broadcasting every moon landing and Mars rover update with pride. So, why the deafening silence when it comes to barrier-like phenomena? The agency's probes have stumbled upon cosmic anomalies for decades, unexplained plasma surges, magnetic walls, regions where space itself seems to push back. Yet official statements dismiss these as instrument glitches or unmodeled interactions. The question isn't just what NASA knows, it's why they're not shouting it from the rooftops. One possibility is sheer uncertainty. Space is messy, and even the smartest scientists can't explain every blip on a sensor. When Voyager detected the heliopause's chaotic energy spikes, it took years to confirm they weren't calibration errors. But here's the rub. NASA's own reports label these findings as unexpected and poorly understood. Ignorance might explain the silence, but it doesn't excuse the lack of public curiosity. Imagine if oceanographers found a swirling, unexplainable vortex in the Pacific. Would they quietly file it away or launch a fleet to investigate? Then there's the secrecy angle. The agency's history is peppered with black-budget projects and sudden data purges. Take the infamous Moon Pyramid incident. Apollo astronauts reported seeing geometric structures, only for the footage to vanish into classified archives. Fast forward to modern probes, and the pattern holds. When the New Horizons spacecraft spotted odd, reflective patches on Pluto's surface, raw images were delayed for months, with murmurs of processing issues. Coincidence, or a habit of gatekeeping discoveries that defy the textbook? But the darkest theory is deliberate suppression. Some whistleblowers claim NASA higher-ups operate under a cosmic quarantine directive, a silent policy to withhold evidence of phenomena that could destabilize society. Former astronaut Edgar Mitchell spoke openly about a culture of secrecy surrounding extraterrestrial contact. If even a fraction of that is true, barrier-like discoveries might be buried not because they're insignificant, but because they're too significant. After all, how would humanity react if NASA announced, say, an invisible energy fence around the solar system? Panic, apathy, or a desperate rush to breach it? Yet for all the conspiracy theories, the simplest answer might be the most frustrating: lack of proof. Science demands repeatable results, and space is vast. The Voyager's detections at the heliopause were groundbreaking, but they're just two data points in an ocean of darkness. Without a fleet of probes to map these anomalies, NASA could be waiting quietly, patiently, for irrefutable evidence before appending astrophysics. But silence has consequences. When official channels go mute, speculation rushes in. The Galactic Barrier might be fiction, but the vacuum of information around real cosmic frontiers fuels endless conjecture. Maybe that's the real lesson here. In the absence of answers, we don't just imagine monsters, we invent entire mythologies. And whether by design or accident, a quiet stance ensures those myths will keep growing, unchecked, until the day the stars finally whisper back. Warp drives aren't just the stuff of sci-fi anymore, they're the subject of legitimate physics papers, meticulously calculating how to bend space-time itself. Imagine harnessing the energy of entire stars to compress the fabric of reality in front of a spacecraft while expanding it behind, creating a bubble where the ship rides a wave of distorted space. This is the Alcubierre drive, a theoretical concept born from Einstein's equations, and it's precisely the kind of technology that might one day crack open a real-life galactic barrier. The math suggests it could work without violating relativity, but here's the catch. It requires exotic matter with negative energy density, something we've only glimpsed in quantum experiments. Yet labs like NASA Eagleworks are already testing microscopic warp field perturbations, hunting for even a whisper of proof. If a structure like the barrier exists, warping space around it rather than pushing through might be the only way to cross unscathed. Then there's quantum tunneling, a phenomenon so bizarre it feels like magic. At the subatomic level, particles occasionally teleport through barriers they shouldn't be able to cross, as if the universe forgets to enforce the rules for a split second. Scale that up, and you're flirting with the idea of macroscopic tunneling, slipping a starship through a cosmic wall by exploiting quantum uncertainty. Theoretical work at CERN and Fermilab explores how high-energy particles might phase shift through dense matter, and some models suggest that under extreme conditions, entire atoms could briefly tunnel across impassable voids. The barrier, if it's a zone of distorted quantum fields, might not be a wall at all, just a veil, one that could be parted with the right frequency of vibration. But the wildest contender, neutrino conversion. These ghostly particles pass through entire planets like they're not even there, barely interacting with matter. Recent experiments like IceCube have detected neutrinos from galaxies billions of light years away, proving they're cosmic ultramarathoners. Now imagine a spacecraft that doesn't fight the barrier, but transforms into something that ignores it, disassembling into a neutrino swarm to slip through, then reassembling on the other side. Far-fetched, maybe, but quantum teleportation already moves particle states across labs, and bioengineering is inching toward molecular reassembly. The barrier's greatest weakness might not be brute force, but an indifference to the rules of solid matter. The common thread in all these theories, they treat space not as an empty stage, but as a dynamic, malleable medium, one that can be tricked, twisted, or transcended. Star Trek's barrier was a test of ingenuity as much as technology, and the real cosmos might demand the same, whether through warp fields, quantum tricks, or rewriting the very definition of ship. The answer isn't just about power. It's about perspective, seeing the universe not as a cage, but as a puzzle waiting to be solved. And if history's any guide, the solutions will be stranger than fiction. So where does this leave us, suspended between science fiction and scientific fact? The parallels between Star Trek's Galactic Barrier and NASA's unexplained cosmic anomalies aren't just coincidental, they're a testament to how imagination and discovery dance on the same edge of the unknown. From Voyager's turbulent heliopause to ancient myths whispering of celestial boundaries, the evidence, scattered, speculative, but undeniably compelling, invites us to reconsider what we think we know about the universe's frontiers. This isn't about proving Star Trek right or wrong. It's about recognizing that the best stories often act as guideposts, pointing to truths we haven't yet uncovered. When Gene Roddenberry dreamed up the barrier, he tapped into something primal, a fear, or maybe a hope, that space isn't just empty void, but a terrain riddled with thresholds, each one daring us to cross. And now, with every probe that stumbles upon a magnetic kink or a plasma surge, with every astronomer puzzling over gamma-ray anomalies or interstellar hums, we're collectively inching closer to answering the question: is the galaxy stranger than we've been taught, or exactly as strange as we've always sensed? Here's the real challenge: staying curious without tipping into credulity. The universe doesn't owe us violet energy walls or psychic metamorphosis, but it does reserve the right to surprise us. Maybe the barrier, as Star Trek envisioned it, doesn't exist. But what if the truth is something even wilder? What if the real cosmic frontiers are stranger than anything a screenwriter could conjure? That's where you come in. The conversation doesn't end when this video does. Hit subscribe, because the deeper we probe into space's mysteries, the more questions erupt, and you won't want to miss what comes next. Drop your thoughts below. Is the Galactic Barrier pure fiction, a metaphor waiting for its real-world counterpart, or something NAS already quietly documenting? Debate, dissect, and dream big. After all, every scientific revolution began with someone asking, what if, and in a universe this vast, the next great leap might just be a single bold question away. But our journey doesn't end here. Imagine this: a planet orbiting the fiery star 40 Eridani A, its surface bathed in crimson light. For decades, Star Trek fans knew it as Vulcan, Spock's homeworld, a place of logic and soaring arches. Then, in 2019, NASA test telescope found something chillingly close, a real exoplanet circling that very star. Coincidence, or something more? The scientists who discovered it hesitated before calling it Vulcan, but the name stuck, as if fate itself had intervened. This discovery raises questions that reach far beyond astronomy. Why does Star Trek's fiction keep colliding with reality? Is it mere luck, or could there be something deeper at play? The same show that dreamed up warp drives and communicators might have been pointing us toward cosmic truths we're only now uncovering. And Vulcan isn't the only example. From nebulae that mirror the show's visual effects to unexplained energy signatures that evoke the Enterprise's encounters, the line between script and science keeps blurring. So here's the cliffhanger. What if Star Trek isn't just predicting the future? What if it's remembering something? Buried in those episodes might be fragments of lost knowledge, echoes of an ancient understanding of the cosmos. Next time, we're diving into the Vulcan enigma. How did a fictional planet become real? Who or what guided that discovery? And most haunting of all, what other Star Trek fiction is still waiting for science to catch up? As we close this chapter, let's borrow words from the show itself, words that now feel less like fiction and more like prophecy. Space, the final frontier. These are the voyages of the starship Earth, its ongoing mission to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no one has gone before. Until next time, keep looking up. The universe has more secrets to share, and the next revelation might be closer than you